Hello and welcome to this insanely overdue video. So overdue in fact, I was originally aiming to have this project done about a year ago. And as always, this project became far more complex than I had originally envisioned. This is the first part of a 3-part series covering this project. I had originally planned to keep this as a 2-part series, but as my recording was 40 minutes long, I decided to split this into two 20-minute parts. With this part being an overview of the prop, its functions and features, as well as the story behind the troubles and tribulations of its development. And trust me, this project became a real unending nightmare, and has left me really rather burnt out. So much so I've actually struggled to even start writing this very script I'm performing right now. But this build is finally finished and ready to show off. In part 3 of this video series, I will go into some depth of how I programmed this tricorder, including some breakdowns of the UIs I developed and a breakdown of some of the hardware as well. But for now, let's have a quick look at the finished prop. Many people who haven't been following my thread on the replica props forum might wonder how this is any different to the tricorder I built nearly 3 years ago. Which will be a fair question, as on the surface it doesn't look all that different. However, when I open the hatch on the back, it all starts to become clear when I compare it to the interior of the old prop. Right away you can see that while it's still complex, the electronics are far tidier and more integrated into an almost singular board. Apart from this blue boost converter board which I had to hack in, but more on that later. One of the main complaints I had of the original prop was how I used many hobby boards and a lot of hot glue. I did in fact have several custom PCBs in the original design, but I did agree that with all the wired soldered boards it wasn't the best and probably wouldn't last that long. I also had some interest from a friend to build them this prop, so I got about designing a new fully integrated board using this original design as a template, and I came up with this. This board took all the components used in the old design, but set them into a single board, and everything was set for me to deliver this finished prop to this person by around Christmas 2019. But inevitable technological fate decided it was not to be. You see, as you may remember in my first build, I used the Nextion display to run all my scanning UIs of the tricorder. And this was also the plan for this build I was going to send. However, on receiving the new set of displays, I quickly discovered that the quality of these displays had fallen drastically. Not only was the colour quality lower, they used a far cheaper LCD panel that had an extremely narrow viewing angle. So narrow in fact you couldn't even look at the display head on and see a uniform colour across the display. I was really not happy with the quality of the display, and showing it to the guy who I was building this for, he was not happy either. I made a detailed forum post about it at the time. A link to that is in the description. At this stage, I would wholeheartedly say, do not buy this display, do not support this company, they are crooks and they do not deserve your money or your time. With that little rant out of the way, back to the tricorder. While developing the new all-in-one PCB I was making, I was constantly thinking about the further development, predominantly with the display itself. Even before completing the original tricorder, I had already started to dislike Nextion and was looking for alternatives. And a couple of years before, while working on my earlier speedometer project, I discovered and started to work with FTDI Eve chips, and immediately felt that this was the next step forward for the tricorder. Not only does this give me full control of the hardware used and what LCD panel I want to put in, using the Eve chip will also give me access to a much higher fidelity of UI rendering, being able to produce far more complex and interesting graphics than the Nextion ever could. So when talking to this guy, I proposed if he gives me time I will develop the new system. He agreed and I got underway. Last year the Stargate became the main project, but I was still working on the new tricorder on the side. The first thing I did that year was design and build this hardware development board for the FTDI, now Bridgetech FT810 graphics chip. This development board was designed to fit a multitude of common LCD panels that supported parallel RGB display connections, using a door-to-board breakout covering most of the common interfaces. And from here, I started testing a few displays from buydisplay.com before settling on the 2.8-inch IPS panel here. I then made a test UI as a benchmark to figure out how best to develop the UI pages, and this is what I posted in April 2020. And from there I began to design a new PCB, as well as started tweaking the design of the chassis to fit the new PCB design. One of the changes I made is before I designed it for FDM printing, but in this case I was going to print these parts wholly on my resin printer, with the aim to have a more accurately detailed print, but also to reduce post-processing work and time. Over the course of the year, in between working on my Stargate and other projects, I went through several iterations of the PCB design, including correcting mistakes I discovered, such as somehow completely removing the 5 and 3 volt rail traces from the PCB before I ordered them. And by around January this year, I had finally settled on my PCB design, and it was time to finally get this thing constructed. Over the course of that winter, I had already started printing off the new Tricorder parts, and it was already my plan to do 3 builds to begin with, as I felt it would be more efficient to make 3 at the same time rather than 3 one after the other. Yep, these were smart thinkings. I started assembling the PCBs and adapted my earlier test code to run on the boards to make sure they were working, and so far so good. Around this time, I had also tested the various power circuits, and I had faith these were fine, as I had used variations of these circuits before, but more on that later. Anyway, I was starting to assemble the new tricorders. While doing so, disaster struck. While handling my old tricorder, I accidentally dropped it and it landed with the door open. At first, when I had a look at it, all seemed fine, but a little later in the day I had noticed that the hinge had cracked. And as you may remember from my previous tricorder video, I had printed my hinges in resin and fed wires through them. At the time I felt this was the best option, and my resin seemed strong enough to do the job. I tried to repair this by carefully feeding superglue into the cracked hinge. However, this didn't work out and made things worse and seized up the hinges. This destroying the hinge and sadly my build, RIP Voyager Tricorder version 1. While this is indeed a shame, this also highlighted an issue I was thinking about in the back of my mind. Resin is just too fragile for such a regularly used mechanical part. By this point I had already designed and built the new hinges for the new tricorder, incorporating the new 4-wire system I had designed for this new version, taking the 5 lines per hinge down to 2 lines per hinge, but with the old tricorder breaking I had to rethink my hinge design. The first best option would be to use some off-the-shelf brass hinges like they did in the show. However, I could not find any hinges that both looked similar to the ones I had designed, nor similar to the ones used in the show. At least none that I could adapt to run 4 lines through to the door. In this new design, I decided to add a second microprocessor into the door. This way I could pass all the buttons and LED data to and from the door to the main microprocessor in the body via a 2-wire serial. So I only needed 4 lines, 5 volts, ground, serial TX and serial RX. After failing to find any off-the-shelf parts, I decided I would have to make my own special brass hinges, once again adding complication and time to this project. After wasting more time on a couple of failed orders of brass strips that didn't turn up, I then ordered some brass sheet to cut into strips myself on the bandsaw. After carefully cutting the strips and not my fingers, I then cut these strips into smaller lengths and used a desk vise to press the brass strips into hoops around a hardened steel rod. Once all the hoops were pressed, I took the hoops off the rod and used the vise again to slightly close them a fraction more. This will give a good contact grip onto the steel rods I was going to use as the pins for the hinge to pass the voltage and the 2 signal lines through. I slipped these tightened hoops back onto the rod and then soldered the hoops to set them. I then gently filed all the hoops to make them look uniformly round. With the hoops ready, I needed to set them into frames that will hold them in place. In this design, while there is still a central resin hoop to keep it looking like a 5-hoop hinge, it's more there for aesthetics and partly as a guide for holding the hinge pins in line. But all the stress will still be within the brass hinges themselves. Even though I believe this would be stronger than the original design, I still wouldn't want to put that to the test and drop this in the future. With the construction pretty much done, my next problem I had to deal with was finding the right paint for the props. And this has proven to be harder than it really should have been. In the first version, I had used a hand-mixed set of airbrush water-based acrylics. This gave me a very unique shade of slightly off warm grey, but this undercoat shade was hard to reproduce and was really fragile and prone to scratching off. At least until you put the lacquer coat on, but even the lacquer could cause the paint to blister if the first coat went on a little too thick. So my first job here was to try and find a close match in an off-the-shelf spray paint. Now where I live, that means going to the local Halfords, as there are no art supplies nearby. While Halfords does have a large range of spray paints, finding the right shade had proven to be really very difficult. And the task made doubly hard as the preview strips on the cans did not accurately represent the final colours at all. But after a while wasting loads of money on different cans and testing them myself, I finally settled on one can that was really close to the original colour. However, this proved to end up being more of a pain in the arse later on. But this talk of paint is getting a bit ahead of the narrative, as much earlier on from changing the colour of the paint, I had already started to write the program that was going to sit on the microprocessor. I will go into more detail about the program's organisation and layout in part 3, but for now I will briefly go over what I did. The software development for the Tricorder ended up taking far longer than I had anticipated, as while I did have an idea of what I was going to do, actually implementing everything ended up being a plagued with little issues along the way, including some interesting problems trying to achieve some complex visual effects displayed in some of the UI pages. While I was waiting for an order of PCBs to arrive, I took this downtime to begin writing the core system for the Tricorder. This was mostly bulk writing the code without testing, so I was sure most of this wouldn't just work, but I managed to build up most of the base framework and core system within about 3 weeks. Once the PCBs turned up, I started putting them together and started testing the code and correcting what mistakes and bugs I could find. With the core framework mostly working, I then started to integrate some of my old Tricorder code from the previous version of the Tricorder, mostly the LED sequences and some of the button handling code, much of which I ended up rewriting anyway, as I then had to adapt and write some of the interpolation code for the new system. I also changed the main microcontroller from an ATmega328 to an STM32F103 as I knew I needed the extra performance. I also rearranged what LEDs are driven by what LED drivers and from what microcontroller GPIO. I then updated all the defined addresses for each LED and edited the various LED sequences to reflect the new changes. With the change in microcontroller and the program now running a multitude of complex real-time tasks, including having the LCD and LEDs updating on a regular timed basis so not to ruin the visually immersive experience, I needed to choose a robust scheduling system, as the thread scheduler library for Arduino I was using before would not be up to the task, so I went with the well-known FreeRTOS. This allowed me to have all my side tasks running without having to worry about writing non-blocking code across the whole system. And more importantly, run everything on time to not break the immersive experience, as any delay in the LCD or LEDs updating will be perceivable to the user. Again, I will go into more detail about how the program is organised and laid out in part 3. Once the core system was organised, it was time to actually start writing the content of the program, this being all the UI pages of the Tricorder displaying the various scanning visual effects. This undoubtedly took the majority of my time. While some of the simple UIs were made fairly quickly, several days to a week, some of the more complex UIs like the Geoscan UI actually took several weeks to make as I was pushing the graphics hardware to its limits with what I was doing, and also writing complex scripted sequences for the UIs to run on. But like I say, all this took far longer than I had anticipated, which is why I've been so thin on new content for my YouTube channel this year. Once the program was complete, I was finally on my way to being done, but around September I had more delays causing more troubles. It took pretty much all of the summer to complete the program. Once the program was complete, I was finally on my way to being done. Like I say before, my plan was to build 3 tricorders in this run, but hardware had started to fail on my other 2 builds. This was mainly caused by problems with soldering. I think it's a mix of cheap, badly flowing solder and my use of single core wrapping wire to connect the various daughter boards within the PCB. This is undoubtedly the main problem now with this current version. After various attempts to fix these 2 builds were inevitably unsalvageable. One main issue with this current design is I still need to sandwich the electronics into the build. There is currently no way to remove the PCBs without causing significant damage to the chassis. And this is in fact something I'm currently working on fixing, but a little more on that shortly. I still had one build working and it was time to finish up and get it ready to make a video on, and then send it to my very patient friend. But things are never that simple. It's now late September, moving into October, and the weather was quickly turning. I had to quickly get the lacquer onto the tricorder, and as luck would have it, the lacquer bloomed, and it bloomed badly. Not only did it bloom, it also reacted badly to the rubbery bumper paint I had used, and cracks were forming along the seams where the front face was glued and filled. It was this time I realised that the bumper paint simply was not going to work, but also I had to figure out how to deal with the lacquer blooming. I live out in the countryside, and one thing we have here is damp. Moisture in the air is something that can't be avoided here, but it's that moisture that also causes lacquer to bloom and quickly go cloudy. I had to come up with a quick, cheap way to get the moisture away from the tricorder when I was painting it. In the end, I got myself a small PVC growing tent for potted plants, the kind of thing you can use when you don't have a dedicated greenhouse. I also got myself a small desktop dehumidifier and some humidity meters and ran it inside the tent, and it appeared to work. I was able to remove most of the moisture from the tent, and on testing, this fixed my lacquer bloom problem. But I had one issue left, the rubbery bumper paint. This paint was a pain. Unlike most acrylic paints, this doesn't sand back well at all, so I ended up having to use acetone to strip the paint right off and re-prep the prop. I had originally painted the parts in separate to get the best manufactured look possible, but I couldn't do that now, so I had to carefully mask off the front sensor and emergency buttons and gel pack. But what should I do about the colour? After several months of having already settled on this paint, in the end I opted for another car body paint that was somewhat approaching the original colour, but this time it was a rather metallic paint. Luckily, the lacquer somewhat dulled the metallic finish to something more reasonable. Of course, I had to then carefully strip off all the old paint and then repaint the prop while it is in its constructed form. Now, this paint does not closely match the original flat colour I had made, but ended up becoming a reasonable alternative. So I decided to just accept this is the new colour now. I won't lie, I do prefer the more plastic look of the old colour. Something about it just felt more right. But the metallic look does fit well with Voyager's aesthetic for many of its other props. So now it's coming to early November. This is it, right? It's finally over. After all this time, nearly a whole year of full-time development and a couple of years of on and off development, all of which has left me really burnt out, and I desperately want to get on with other projects. No, it's not over. Find out about the final problems I had in part 2, where we also get to take a closer look at the running tricorder. If you want to help support me, please consider subscribing to my Patreon, and if you like, you can also give a one-off donation through my GoFundMe. The links are in the description. If you like the work I do, please also consider subscribing to me here on YouTube to keep updated on my projects. See you in the next one. Stay safe, take care, and goodbye.